Welcome students. In this video, we're going to see about another set of instructions. So another set of instruction comes under the category of program and machine control instructions. Sometimes this will be called as a jump or looping instructions. Okay. So first we're going to see that was a call address of 11. Okay. So first, what is call instruction? So, call instruction will be mainly used for calling the subroutine program. So, subroutine program means a small set of program is written and stored in some memory location. Whenever required, a main program will call that subroutine program. That subroutine program is executed. After executing that subroutine program, the control will be again transferred to the main program. Okay, it's simply like calling a function. Okay, in high level languages there is a term called calling a function. So function means what? That it's a small set of program or small set of instruction. It will be performed whenever it is called. Okay, so same thing here we are having. So the call instructions are nothing but we're going to call the set of instructions whenever required. After executing those set of instruction, the control will come back to the main program. When you call the subroutine program, control will transfer to that memory location and start executing from there, and then it return back to the main program. Okay. So here a call means, so absolute call is nothing but it will call the subroutine program which is with the memory address size of 11-bit memory address. So 11-bit memory address means 2 to the power 11. So it will be 2 kilobyte memory page. That means it can go up to, that means it can able to call the instructions up to maximum of 2 kilobytes range. Okay, beyond that it can't able to call any memory location. So it requires only 11-bit memory location. Okay, so a call, after that you have to give a memory address. This memory address should be a 11-bit memory address. So maximum it can able to call was within the range of 2 kilobytes. Okay, so this is one kind of call instruction. Another kind of call instruction is lcall. So lcall is a long subroutine call. So here what we are going to give was 16-bit of address. So 16-bit of address means it can able to call the memory program, or it can able to call the set of instruction within 64 kilobytes of memory location. Okay, so maximum it can able to go up to 64 kilobytes of memory location. So a call means we have to give 11-bit address. L call means we have to give 16-bit address. Okay, so RET instruction. So every subroutine program you are calling means the end of the subroutine program should be a RET instruction. Okay, so this instruction should be provided so that a CPU knows that this is the end of the subroutine program. So it has to return back to the main program. Okay, so this is like a return instruction. Okay, so this RET instruction is utilized for returning from the subroutine program. Okay, this RETI is specifically utilized for interrupt service routine. Okay, so interrupt service routine is nothing but as previous instructions we have seen a call. That means we are programmer is calling specifically. Okay, so but interrupt functions are there, interrupt service routines are there. That is a separate program which will be executed whenever an interrupt signal is occurring. Once the interrupt signal occurs, automatically the CPU will goes to that interrupt service routine and start executing that instruction. Okay, once that instruction is executed, it has to return back to the main program. So how the CPU knows that that is the end of the program? So this instruction will be provided to say that this is the end of the program, so that it can return back to the main program. Okay, so this is specifically for return from interrupt. So Another set of instruction is jump instructions. Previously, we have seen that call instruction. Call instruction means we are calling a separate set of program which is stored in a separate memory location. Okay, so that will be having a return. Okay, jump instruction means we are transferring the control within the program itself. Okay, so it's like a go to function, go to statement kind of thing. Okay, so jump instructions will be utilized for transferring the control of the CPU within the program itself, main program itself. So for a jump is absolute jump. You have to give 11-bit address. That means it can able to jump up to maximum of 2 kilobytes. Okay, so absolute jump you have to give 11-bit address. So L jump we have to give 16-bit of address, which is a long jump. Okay, so we can able to jump up to the memory location of 64 kilobytes. Okay, so another one is short jump. Short jump we have to give, it's a relative short jump. So we have to give 8-bit of address, or the jumping will be between 8 bytes, 8 bits. So that means it will be 255 only it can able to jump. Okay, that's why it is called a short jump. So the program, the data, the control transfer will be between 0 to 255. Okay. So another instruction is jump. Here is just jump out of A plus DPTR. That means what will happen, the memory location where the control has to be transferred will be calculated from these two registers. So value in DPTR and value in A register will be added. Okay, suppose if you are having a DPTR value as something called 4100. Okay, A value as 02. So the result of these two addition will be 4002. Okay, so that 4002 is the control transferring memory location. So the CPU will transfer its control to that memory location. So this is jump, simple jump. Okay. So another instruction what we are going to see was jump on J is at relative address. Okay, so these instructions are conditional jump instruction. What is conditional jump instruction? So it checks as a condition. If the condition is true, then only it will transfer the control to that corresponding memory location. Okay, here J set means jump on 0. Whenever the result of accumulator is 0, then this condition becomes true. Okay, whenever the result in, or whenever the value in accumulator becomes 0, so then this instruction becomes true, so that it will transfer the control to the corresponding memory location what it has been mentioned here. If the accumulator value is non-zero, this condition becomes false, so this will not get executed. Okay, so when true condition, then only this will be getting executed. If it is a false condition, this instruction will not get executed. So JZ means jump on 0. That means if accumulator value is 0, the condition is true. Okay, another is JNZ. So here JNZ means jump on no 0. That means if the accumulator value is not 0, that means accumulator value is not equal to 0, then the condition is true. Okay, so in that case it will jump to the corresponding address. Suppose if the accumulator value is 0, the condition becomes false, so this will not work. Okay, this will not get executed. Okay, so previous instruction is one way of checking 0, this is another way of checking 0. So another instruction is JC. So JC means jump on carry flag is set. Okay, so we are having a carry flag in our PSW. Okay, whenever that carry flag is set means we need to check it. Okay, so this instruction will check the status of the carry flag. If the carry flag is 1, then this condition will be true, then the control will be transferred to the corresponding given address. So jump on carry. Another one is jump on no carry. Jump on no carry means if the carry flag is not set, then this condition is true. Okay, that means if the carry flag is 0, then this condition is true, then the CPU will transfer its control to the corresponding memory location. So this is one way of checking carry. This is jump on carry also we can use, jump on no carry also we can use. That depends upon what kind of program you are writing. Next instruction what we are going to do is jump on bit. So jump on bit is, it checks a value of bit. If the bit value is 1, that means the condition is true, because jump on bit, what is that bit? We are going to check this bit value. If this bit value is equal to 1, condition becomes true, then it will jumps to the given memory location. So jump on no bit is nothing but ulta of this bit. So jump on no bit is, we are going to check the bit if the value is equal to 0 or not. If the value of the bit is equal to 0, then the condition becomes true, then the control will be transferred to the given memory location. So here in these two instructions, we are going to check any bit. So bit means it may be port bit or it may be a carry bit, anything. Okay, so we are going to check the status, or we are going to check the value of the bit. So if the value is either 1, jump on bit will becomes true condition. If the value is of the bit is 0, jump on no bit becomes true condition. Depends on which instruction you are using. Okay, so these two instructions used to check the status of the bits. So next instruction is jump on bit and clear the bit. Okay, so here what is happening was, it checks the value of the bit. If the bit value is equal to 1, condition is true. So once the condition becomes true, what will happen? It will jumps to the given memory location. Before jumping to the given memory location, it clears the same bit. Clears the same bit in the sense, it makes the value equal to 0. Okay? So I'm repeating, jump on bit and clear bit. What is happening means, we are going to check the bit value. If the bit value is equal to 1, it becomes true condition. Then what will happen? It will transfer the control to this given memory location. Before transferring the control to this given memory location, this instruction will make this corresponding bit equal to 0, then it will goes to that memory location. Okay, it also clears, checks if it is 1. If it is 1, then it makes it 0 and then jumps to the given memory location. Okay, so that is what happens in this instruction. So next instruction is compare jump or jump not equal. Okay, compare and jump if not equal. That is what this is. What will happen? It compares two data. In this condition, for example, what is happening is, take this example. We are going to compare the data of A value, and also we are going to compare the value stored in this memory location 55. Okay, so assume that if A is equal to 36 and 55 memory location, we are having a data of 63. So this 36 and this 63 will be compared. Okay, so we know that A value is 36 and this value is 63. Both are not equal. So condition is true. Okay, so when this condition is true, it jumps to this corresponding memory location, say L1 here. Okay, so before jumping to this corresponding memory location, depends on what value stored in A and this memory location value, carry flag will set. Okay, for example, if A value is less than the given memory location value, means carry flag becomes 1. Suppose if A value is greater than this given memory location value, means carry flag becomes 0. In our example, A value is 36 and given memory location value is 63. So A value is less than 63. So carry flag will automatically set. Okay, then it will jumps to this given memory location. Okay, since it is less than this direct memory location address value. Okay, that's what. So same jump on not equal instruction has other 3 different way of representing. So you can compare A data with immediate data. You can compare register data with immediate data. You can compare indirect addressing data with immediate data. So you can compare two numbers like this also. Okay. So the working principle is same as the previous example. Only thing, the two data from which two data we are going to compare, that will be varied. So next instruction is DJNZ Rn comma REL. So which is nothing but in this instruction two operations are going to happen. First one, it decrements the value in this specified register and it checks does that value becomes 0 or not. So simple example, DJNZ R2 comma some memory location I have given here. So what will happen, whatever value stored in R2 register will be decremented by 1. Then it checks does that value becoming 0 or not. Okay? If that value becomes 0, that means the condition is false. If the value is non-zero, that means the condition is true. So example, you see, assume that R2 equal to 36. Okay. So now whenever this instruction is executed, what will happen? Whatever value in R2 minus 1 will happen. So now R2 becomes 35. As this value is 0, no, this is a non-zero. Now this condition is true condition because we are checking non-zero only. So 35 is not a 0, not equal to 0. So this is true condition. So it jumps to the given relative address. That means this loop, it will jump to this memory location. Okay. So likewise, DJNZ can be made for direct memory location values also. So here 55 is our direct memory location value. So it decrements the value in that 55 memory location and checks does that becomes 0 or not. If it is not equal to 0, then it becomes true condition, then it will be jumping to the given memory location.